All right, Doosan G30 7 series. There's the model and serial. And there is a P0650 MIL circuit, open or shorted. And gonna lean towards shorted. Because the check engine light is on. All right, and you see that there are no other codes. The unit has any other running conditions. This is the only code. We're going to assume that we have a short circuit, keeping this bulb on. All right, so if you go to the wiring diagram, you go to the instrument panel where it breaks out the instrument panel. And if you see over here, it says MIL. So this one's nice, showing you that the polarity it needs in order to make that MIL indicator come on. So we need a negative on this circuit, wire number 27, and more than likely we are getting a negative from another source other than the ECM. It could also be the ECM, but I'll show you how to eliminate the ECM and to see if you actually have a short circuit. So you follow wire number 27 MIL, follow it over, it goes down, goes over, and it goes over to over here, connector A1, and you can see it goes to 23, right? It's circuit 49, but it's pin 23 on that A1 connector. So this is going to continue on to the next page, right? So we're going to continue over. So you got A2, A1 connects to A2. So we're going to look for 23 right here, blue and yellow, and we're going to follow it over, see it goes up right here, over, up, and over, and up again, and you can see it goes to connector VIC2 to ECU, and you can see this is connector VIC2, pin 11. This is the connector where we're going to split the circuit. We're going to split it here. We're going to disconnect wire 11 from that connector, and we're going to isolate the ECM and the rest of the harness. I made a mistake here. The cursor is showing VIC1 instead of VIC2. VIC2 is to the right. VIC1 and VIC2 are the same type of connector. All right, so to depin this connector, remove this white retainer. It just pops out. And then if you look, there are these little gray tabs right here. And if you can see, I'm moving it away. That's what you got to do. So I'm just gonna do the easiest one, which should be this one. So all I'm gonna do is put a pick or a tool here. All I'm gonna do is just go right up against the terminal and move it away. Oh, I was doing the wrong one. Move it away, and it just pulls right out. and then to put it back in, you look at the orientation, so you know that that gray release rides up along here. That's where it locks. It can't go over here because it will never lock over here. So just put it back in, and all you do is just push it in until it clicks. Take your retainer, push it in, and you're all set. Can you send that? This is the view of that connector. All right, you see you have your indexing tabs here on either side, and the clips on the top. So I'm looking over here, right? So looking for pin 11, which is going to be on the third row. Third row. This terminal right here, right? And if I go over here, where it connects into on the back side, this is where I've split it. So this part is going to the ECM. This part is coming from the display. And I'm just going to reconnect this. All right, so now what I want to do is I want to trick the ECM to think that the bulb circuit is intact. And I want to see the ECM control the check engine light. I want to eliminate the ECM as a possible cause for shorting out this MIL circuit, and also eliminate this end of the harness that goes down to the ECM, right? So this is going to the ECM, this is going back to the display on the bottom, and I'll show you that next. So now what I got is I got a LED test light, preferably LED. If you're going to use an incandescent, use a higher resistance incandescent test light. You do not want to overload the driver that controls that bulb circuit. It's used to controlling an LED. If you are controlling an incandescent light bulb, it may draw too much current for that driver to handle, and you could possibly damage the ECM in your testing. So preferably LED style. So all I got is a jumper connecting this to the ECM, and I have my test light. I have the clip on battery positive, so when I touch the ground, test light lights, right? Since this bulb circuit is negatively controlled, what I'm going to look for is when I create a fault, one, I want to look to see if this lights up immediately when the when the check engine light comes on. And then secondly, if it doesn't, what I want to do is create a fault so that the ECM can control the MIL. Since I've eliminated this from the dash, this is now my check engine light. What I'm going to do, I'm just going to turn the key on. Now this is normal. Key on, as you know, when you just turn the key, this is the on position, the check engine light will illuminate. So this is normal. What I want to see is when I start the engine, and as long as there's no other faults, I want to see this go out. So light goes out, which is good. So now what I'm going to do is I'm going to create a situation where the ECM has to turn on the MIL circuit. Right away, right there, that is pretty much telling us where our problem is. The check engine light is on. All right, it's either going to be in the display, the harness, we have a short. But I just want to see the computer control it. So all I'm going to do is I'm going to disconnect this mass airflow sensor. All right, so I'm going to disconnect the mass airflow sensor. Mass airflow sensor disconnected. ECM controlled my check engine light. And what I should have a code for the mass airflow and intake air temp circuit. That should be the only code I have. And here you go, mass airflow sensor circuit, and you notice the P0650 is gone. So this leads us away from the ECM being a possible cause for that check engine light to always be on, and we're going to look in the harness and the display as a cause of this malfunction. And isolated the ECM from the rest of the harness, and we were able to see that the ECM not only could control the check engine light, but it was also not the cause of why the check engine light was on all the time. So what we're going to do is we're going to go right to the display, and we're basically going to do the same check. We're going to depin wire. All right, so to depin this connector, all you're going to do, this is just like the jacks. You're just going to push this tab out, and you hear it click. You can see these two tabs raised on this side. From that point, since we want to take out this wire, all you're going to do is simply pull it out. And then that's it. And to put it back in, this one, it really doesn't matter. You just want to put it in so where it goes straight. And then you want to push these tabs back down. But before you do that, you want to make sure all these terminals are fully seated up. If any of them are pushed back, the tabs won't go down. So you just push them down one at a time. Nice and easy. Double check. And that's it. All right, so I got wire 27 depin from the connector going to the display, and I have my test light hooked up to battery positive and acting like my check engine lamp. All right, so now what I'm going to do is going to turn the key on. It's doing the bulb check, that's normal. I'm going to start it up. Check engine light goes out, as it should, as long as there are no codes. No fault detected. So, check engine light is out. What I'm going to do is I'm going to disconnect my MAP sensor again. And you can see my check engine light is now on, verifying that my ECM is operational and not the cause of the short. And since I got that wire disconnected, my check engine light is on the dash. There is an issue with the dashboard itself.